In this series of videos I've been restoring and repairing this Hazeltine 2000 smart terminal. Through the series I've had quite a few complaints about the high-pitched whining noise that this machine was making, and I left the noise in. I'm not going to filter it out. I explain why in the videos, and we've now got to the point where I've started the final reassembly, and as you can hear we're getting quite a lot of noise coming out of this unit, and this is from the cooling fan. Now normally I just replace the bearings without mentioning this, but I thought it was quite amusing in this case. I don't know how well this is coming across on the microphone, but the fan noise coming out of this is many times louder than the whining noise was. In fact, I'm having to raise my voice, so hopefully you can hear me. So as with all equipment, especially old equipment, you need to put some perspective on what your expectations are from it. So next step was going to be to show you some forms, how to create forms, look at some of the smart features of this. But before we do that, obviously I'm going to deal with this fan noise. It's not really, just turn that off so you can hear me. It's not really going to be feasible to try and explain anything with all that racket going on in the background, and I can't really just disconnect the fan with the enclosure on because the boards in the rack get hot fairly quickly. So what I'm going to do is take the fan out, replace the bearings. I've explained that in previous videos, but I thought I'd just show you a before and after in this particular video so you can see really what difference it makes, especially on an enclosure like this that tends to resonate quite a bit. So I'll take the fan out. I'm not going to show the bearing replacement. I'm just going to take the fan out, replace the bearings and refit it, and hopefully you'll see the difference. So that's the fan noise dealt with, and hopefully you can appreciate it is very much quieter. Just now a very subdued humming sound coming from the terminal, but certainly we've gotten rid of the horrible clanking harsh noise it was making, and also having the cover on has greatly reduced the high-pitched whine. It's still there, that's an inherent part of using these machines, but it's now quite pleasant, quite livable, and it's now not the noisiest piece of equipment in the lab. So next step is we'll have a very quick look in this video at the smart features this has. I'll give a brief introduction as to why they're there, what the real purpose of them is, and in the future videos we'll go into this in much more detail. I will be hooking this up to various pieces of hardware, but for the remainder of this video I'm just going to give a quick rundown of some of the smart features that this terminal has. So I'll bring the terminal up into the corner of the screen. Now one thing you possibly may be able to see on the videos, maybe not, it kind of depends on the refresh rate of the camera and how good your eyesight is. You might notice that as the screen fills with text that you'll see some wavering of the text on the screen. And as I've mentioned before, that's because this unit's running at 60 Hz. I'm in the UK, so I'm in a 50 Hz environment. At some point I will be modifying the line frequency for this terminal to match 50 Hz, but at the moment it causes a slight undulation in the display, and that's really why the refresh rate is synchronized to the mains frequency. Hopefully it won't cause you too much aggravation. You may not even be able to tell it's doing it, but if you can see, that's why it's there. So before we start, the first thing to appreciate is the real difference between a smart terminal and a dumb terminal, and why we even needed the smart terminal in the first place. So it's best explained if I start by switching this back to half duplex mode. So in the half duplex and full duplex, it really approximates a dumb terminal, and we can see that if I type characters on the screen, we get the characters appearing on the display of the terminal, and at the same time we get the characters appearing on the PC screen as well, on the emulator that we're running. And we get the same thing kind of if we switch to full duplex. Now at the moment my PC emulator is not set to echo the characters back. So when I type this, although we'll get them on the remote terminal, we won't get them showing on the local screen. And they only appear on the local screen if the remote host or remote unit echoes them back. And the issue this brings up is that if you want to send text to a piece of equipment, then in the dumb terminal mode it sends it kind of in real time. So every time you press a key on the keyboard, it immediately sends that character through to the target machine, which might be fine, it depends what you're doing, but it means that if you want to, for example, have a text editor, then all the editing, line insertion, backspacing, any form of change to what you're entering has to be done by the target machine, so it needs software running on it to do that. And that might be fine, but if you're using something like an ASR33, which is just putting the text out onto paper, you don't really want to keep sending the text over and over again. What you really want to do is complete all the text, edit it, remove any errors, and then send it all once you're happy that it's correct. Even more so if you're repeating what's being sent on paper tape. You don't want to be using reels and reels of paper tape correcting errors that are being made. But you can't do that with a dumb terminal. It just sends the data as you type it in. But with a smart terminal like this, you have a third option that you can switch it into, and in this particular terminal it's called batch mode, so we'll switch into batch mode. And in this mode what we can do, I'll just clear the display. In fact, what I'll do, I'll lower the camera a bit so you can see the display a bit more clearly. So hopefully that's a bit clearer. So in this mode, as I type text in, it appears on the terminal screen, but it doesn't get sent through to the remote host. So it's only being effectively put onto the screen here, and it's being held in local memory on the terminal. And we can go back, we can enter what we want, we can edit it, we can insert lines, delete lines, we can do what we like. And then once we're happy that the text is as we want it, if we want, we can send part of the text, or we can send all the text. In this case I'll send all of it. So we'll transmit the text and it sends what we've entered. It hasn't deleted it. We can then send it again, we can send bits of it, blocks of it, edit it, do whatever we like. So it really amounts to a kind of text editor, and it's very useful for entering text without having to send the data until it's been properly formatted and checked. So that's the first smart feature. It's very useful. Makes a big difference to using something like this, especially if you've got it hooked up to a teletype or something like that. But where the real power of this comes in is in things such as forms. And a form is really a kind of predefined layout on the screen, but it's not sent when the data is sent through to the host machine. So I'll give you a quick demonstration of a very simple form. This is just one I kind of cobbled together. So all we have to do is design the form as we want it. There are two intensities for the text on the display of this unit. The fainter text is the background text, and for forms it's what constitutes the form itself. That's the part of the data that's not sent through to the host terminal when we transmit, and the brighter characters are the foreground characters, and they're that's the entry, if you like, that we're going to put into the form, and that data is sent when we transmit the data. So I'll upload a very simple form to the terminal, and we'll see how it works. So you can see on the screen we now have a very simple layout for a form for data entry. You can make this as complex as you want. You can put separators in, lines, spaces, and make it look however you really want to. And the real power of this comes in when you fill the form in. So you can kind of look at this almost as a reusable paper form. So what we'll do is press the home key on the keyboard. If I now press tab, it takes the cursor through to the start of the first field, and we can then start filling in the data that we want to enter. Notice that the form is in the background fainter text, and the data we're entering is in the brighter foreground text. When we're happy with that field, we can press tab. It takes us through to the next field. I'll just type garbage in here, but you type in whatever valid information you want. Press tab again, takes you through to the next field. Press tab again, takes you through to the next, and you just keep going through filling in the form. Do it again and again. So not only can you fill it in very conveniently, and you've got labels for each of the fields, but if you want to, you can go back and actually edit what you've entered. This hasn't been sent through to the host machine yet, and once you're happy that you've got the entry as you want it, you can transmit it. So I'm going to transmit the data through to the host machine, and as you can see, the data's sent through. The formatting is up to you. You can format it however you want. I haven't actually done any formatting at all here, but you can include formatting characters as part of the background. You can do pretty much whatever you want. It's really down to how you want the form to look. What you can then do is, once you've used the form, you can delete just the foreground and it will leave the background, and we can now reuse the form again, and we can fill it in, and we can keep doing that over and over again. So it's kind of a very convenient data entry. It's not wasting paper or tape on a target machine, and also when you're running at 110 baud, you don't want to keep sending lots of data. So in this case, all we're sending is the actual data we've entered, and we're not repeatedly sending the form data back to the target machine. So very powerful system, and it's all done by the terminal and not by the processor. And again, on very old processors, the more of the workload you can take off it, the better. So how do we go about creating these forms? Now, there are a couple of issues when you do this on modern equipment. Firstly, the forms often use 0 or null characters, and most modern emulators and terminals on PCs won't handle null characters. So just be aware of that. If you use a character that is going to result in sending a 0 value, you need to make sure that the terminal you're using, the emulator you're using, can handle that. Otherwise the form won't look right. In fact, I've created one here that will show you how this form will look if you don't take that into account. So I'll just clear the screen and I'll send you the same form, but with the null blocking issue that I just mentioned. So that form should look the same. As you can see, it's kind of scrambled, and that's because the null value characters weren't being sent. So as I said, that's something you need to take into account if you're going to use one of these. So I'll clear the screen again. So to enter this information, the easiest way is to put the terminal into half duplex mode, and the terminal will support various commands, and you enter those through the keyboard. You can do it from the remote machine as well. So if we hit Control-Shift period or Control-Shift full stop, depending on what country you're in, that gives us the start of a command. It's basically telling the system that we're going to be entering a background command through the keyboard. And we'll then hit Control-Q, which is the command for cursor position. We then have to enter two numbers, that's the X and Y coordinates for the cursor. This is where we're going to start typing the label that we want to enter, or whatever information we want to put onto the form. So in this case, I'm going to just enter two values. I'll enter two nominal values, and as you can see, the cursor's moved across the screen. I now type in the basically the string of characters or the label I want to use. Let's say we want to use name. We enter that, and we then do exactly the same thing again. So if we want to enter another one, for example, another label, we start the same way, Control Shift period, Control Q. We now enter whatever the X coordinates and Y coordinates are that we want to use. And we've gone down one row but in the same X coordinates. And that's all we do. So this is now a valid form on this machine. If I press the home key, notice we go back to the home position, and if I press the tab key, we go to the start of the first field and we can now enter information. It's coming out as a background task here, or background text. So what you have to do to make use of this is, before you start entering data, is put it into batch mode, and then we're ready to go, and you can enter data, move to the next field and enter data that way. And of course, if you're using half duplex mode, the information would be available on your PC emulator, so you can cut and paste it, save it into a file, and then upload it to the smart terminal as and when you want to make use of it. You can create as many forms as you want, and it is a very powerful tool for something, especially back then when this was being designed, and it did save an awful lot of time and effort when it came to entering forms. So though it looks like a fairly simple feature these days, back then when PCs didn't exist, computers were expensive, you often had time shared access to computers, so you didn't want to waste time sending lots of data that was not really needed. So this type of terminal was designed to get around those issues, and it did make a big difference at the time to the way you could make best use of your computer time. Okay, so that's it for this video. Very simple introduction. I will go into far more detail for forms. We'll create some much more complex forms, and I'll go over some more of the smart features of the terminal, but hopefully you can already see that this terminal is significantly different to a normal dumb terminal. Before I finish this video, just a quick response to a comment or a question that was left on one of the previous videos, and how I went about determining there was an issue with the RS232 link. Now, primarily I did it using the scope, and just a bit of thought really. It was looking at what it was doing and going from there. But one useful tool, and one I use quite a bit for various reasons, is this Model 775 breakout box for serial communications. It's an extremely useful piece of equipment, and it's got 100 LEDs on it, and it allows you to not only examine and observe what each of the lines are doing on a 25-way RS232 link, it also allows you to repatch it. So if you want to, you can turn the switch off that links a couple of the pins, the input and outputs together, and you can re-jumper them, so you can change things around. That's how I determined that the two lines were crossed over in the Hazeltine. I could see it on here that it was clear that the lines weren't doing what they were supposed to, and these LEDs, this is self-powered, and the LEDs show the current status of all the lines. So if I've turned the terminal down to 110 baud, you can see what's going on more clearly. But if I press the key, hopefully you can see that the LEDs are doing what you would expect. So you've got pluses, the green LEDs are for plus signals, the green is for minus, and so you can see that they change state in response to key presses. But the handshake lines aren't changing because I've got handshaking, hardware handshaking turned off. But if you turn that back on, then obviously those lines will come back to life, and you'll see exactly what the interface is doing. So it's a very good, clear indicator as to exactly how the interface is behaving. High speed, it's not that useful because the LEDs are quite hard to see if you're running at high speed, but normally the issues that you'll have will show up in static mode, and if one of the handshake lines is stuck, for example, you'll see that fairly clearly on the LEDs. Or you can force them to do what you like and change state and see how the target machine responds. But it is quite clear on a breakout box like this as to where problems might occur and might reside in a serial link. So having a breakout box like this can be very useful for tracking down faults in serial communications, and especially if you're dealing with equipment that doesn't necessarily use standard connections for the serial link. It allows you to cater for that. You can not only see what's going on, but you can re-jumper it and hopefully get it working, and this can save you a lot of time. You usually still need a scope as well if you're getting issues with the actual hardware, but if it's just configuration you're trying to deal with, then this can be extremely useful.